let's look at confidence interval example. This is from a textbook. We are doing an interval estimation for the difference in two population means. And here is the text of the example, which says that a manager wishes to examine the difference in demographics between the customers of two different stores. They have one store in Buffalo, New York. Well, they operate two stores in Buffalo, New York, one in inner city and the other in the suburban shopping center. Now, the manager wants to see whether there is a demographic difference between the customers who shop in these two stores. So they collect samples, random samples from the two stores, and we want to develop a confidence interval for the difference in the two population means. So let's first define what the populations are. And okay, so here the first population is the customers who shop in the inner city. Population 2 is the customers who shop in the suburban stores. Okay. Inner city and suburban. Age of the customers who shop in the inner city, and the second population is the suburban store. And mu sub 1 and mu sub 2 are the mean age. Mu sub 1 and mu sub 2 are the average age of the entire population, not just a sample of this first population and for the second population. And sigma sub 1 and sigma sub 2 are the standard deviations of the ages of these two populations. Now what we require is a 95% confidence interval for mu sub 1 and mu sub 1 minus mu sub 2. And let's first enter all the given information for the problem. So here is the sample information, but first the standard deviation of the two populations are given as sigma sub 1 is 9, sigma sub 2 is 10. So let's enter those two numbers. Sigma sub 1 is 9, sigma sub 2 is 10. And the sample information from the two samples are, so sample size is 36 and 49. The sample means are 40 and 35. And 49 for the two sample sizes, 40 and 35 are the two ages. So since the standard deviations are known, we should use Z formula for the confidence interval. So let's first find the point estimate for the difference in the two population means, which will be the difference in the two sample means. So that's our estimate, a point estimate for the difference in the means. Now the standard error of the estimate is given by the formula sigma S sub 1 squared, given by the formula sigma sub 1 squared over n sub 1, okay, plus sigma sub 2 squared over n sub 2, the whole thing under square root. So this will be square root of, you take the first one and square it and divide by n sub 1, plus you take the second sigma, square it and divide by n sub 2. That would give us the standard error of estimate. Now alpha is, we want 95% confidence interval, so alpha is 5%. Now Z sub alpha over 2, we want the, so we have two tails, alpha over 2 and alpha over 2 on the two sides. Now we want the positive side of the alpha, of the Z value. So we need to use the norm.inv function, norm.s.inv, and we need to provide the cumulative probability. So we take half of the two tails, alpha over 2 being the tail area, and that would result in the cumulative probability of 1 minus alpha over 2. So we do norm.s dot inv, okay, and we need to do 1 minus alpha over 2. So that will give you the positive side of the z value, and then the margin of error is z times the standard error. That's our margin of error, and then we take the point estimate of the difference minus the margin of error will give you the lower limit, and point estimate plus the margin of error will give you the upper limit for the confidence interval. CI stands for confidence interval. So now we need to interpret. So now we are 95% sure, 95% being the confidence level. So confidence level here is 95%. So you can, if you enter it as 95% here, and alpha then is 1 minus that 95%. So we are 95% confident that the difference in the population means mu sub 1 minus mu sub 2. So we can say that we are 95% confident that the difference in the age of customers shopping in the inner city store and the suburban store will be between 0.94 and 9.06.